And when a massive star dies, so it collapses and it kind of ejects all of this media or all of this material in two directions, what we call gamma ray bursts, which are these really violent explosions in space, as some of the most bright, most luminous. The amount of energy that they give off, so it's kind of it's a hard to imagine amount of energy. And if we understand how gamma ray bursts happen, and kind of even the processes to getting all this energy, we are also understanding kind of processes in the early universe, how our universe came about, how certain elements are formed, elements that we're made of.
So we first heard about the possibility of flying a satellite from this ESA call that was at the end of 2016, and we decided that the gamma ray technology that we were developing in the lab, that actually maybe we could take this gamma ray technology and actually make a useful scientific instrument from it, and it would fit in a CubeSat, and we could put together this mission. We were taking everything we knew and just sort of trying to dump it into this document and make it make sense and make it tell a story that someone could look at and say, okay, yeah, these guys have an idea. It looks like they might be able to pull it off. I actually used the words like, what's the worst that could happen? My name is David Murphy, and I'm a physicist in the UCD Centre for Space Research.
My name is Rachel Doherty, and I'm a final year PhD student at University College Dublin.
I'm the systems engineer for AirSat-1.
And I'm working on Ireland's first satellite.
Dans une vidéo sur Twitter, il a mis en avant son combat toujours en cours, selon lui, pour la liberté et la démocratie.
How big is a CubeSat? And I'm thinking because this is one of our pet peeves. When the writers say that it's the size of a cereal box or of a bag of rice. So a CubeSat can consist of one unit up to a multitude of units.
It's 10 by 10 by 10 centimeters,
which is roughly the equivalent of a bag of sugar. No, you cannot use this. My colleagues will hate me.
What household item? You tell me what household item is about that big.
Like a bit bigger than a Rubik's Cube. One unit is about 8 Rubik Cubes. Well, I'm Joost van Russel. I am currently responsible for the ESA Academy, our program in which we aim to prepare the next generation of Europe's space workforce.
My name's Alex Kinnaird. I'm the program coordinator for the Flyer Satellite program, working in the ESA Education Office.
I'm David Palma, and I'm a systems engineer for the Flyer Satellite program of the ESA Education Office. So CubeSat started off in the early 2000s in the US, where two professors decided to create a standard that should make satellite engineering more accessible to students.
And the idea was that students could build a satellite, and they could really build, test, and launch a satellite within a university career, so within like 3 to 5 years.
And this way, CubeSats became an ideal tool, first for education. Nowadays, we do amazing scientific research with them as well. Or in 2017, we launched a call to universities from the ESA member states to come with proposals for new CubeSat missions.
They came to ESTEC, all the teams came to ESTEC, and they made the pitch.
They showed up as really as a team already, same t-shirts, very well-spoken.
We were confident in like our detector technology, and we were confident that we had some good ideas, but we were coming from a place where no one in our country has ever launched a satellite before. A lot of what we were proposing was really, really new to us, and it was about 2 weeks later. We were all having lunch together, and I was looking through this email, and my mouth kind of dropped a bit, and Lorraine looked over and she's like, "What's going on?" I was like, we got it, we're building a CubeSat. Stunned silence, kind of in disbelief, and then stunned silence in like, we have to go do this now. Lorraine like posted a message on Twitter, and it was like, "I don't know how to say this, we're building a satellite.
Oh, that's right. Yes. I'd forgotten that. Years on, I still have that sense of disbelief we're doing this. My name is Lorraine Hanlon. I am a professor in the School of Physics. My role in AirSat is as the endorsing professor, which is how ESA described the academic staff member who supports the teams.
So I heard about a talk that was going on, that a group in UCD were building a satellite, and I went along to this talk, and it was just incredible to kind of hear that this group of students had been accepted by this program, and then even that they were taking on kind of master's and PhD students to do some work on this project. That's what really kind of captivated me.
I mean, after the initial stunned reaction, the panic set in a little bit, I suppose, when we realised that we had nothing in terms of resources. We had people, but we had no funding. So I did start knocking on doors, and the response was, of course, what can we do? How can we help?
Hey, I'm Jack. Every day I get on the bus and I go to Dublin, and I go into a very loud room with fans where I test some stuff that's going to go to space. And I'm going to make sure that once it goes to space, it's going to work, hopefully, for the next few years. I don't know who came up with AirSat, but that's the best thing we've...
How's Lorraine?
He walked into my office and said, "What will we call it?" Some people don't like it.
I didn't like it at first. And then she sold it on me.
Cut.
Yeah. She sold me on it. We felt like a little bit outclassed there, or at least that we were the scientists who had come to an engineering challenge.
So it's really easy to get hung up on the engineering, I think, when you're building a CubeSat. So building a CubeSat is an engineering task. But like the point of having the CubeSat isn't to perform either a technology demonstration or to do some science.
There is not a recipe to build a CubeSat, and it depends really on what kind of science do you want to do, what kind of engineering do you want to do, do you want to demonstrate some technology?
My work mostly focuses on GMOD, the gamma ray module, which is our primary science payload. So we have a little crystal, it's about this size, and the gamma ray photons come in and they interact with the crystal, and they produce light that we can see. And we have little sensors in there that detect this light and then turn it into an electric signal, so we can then process that and make our light curves and understand kind of the event that happened. And then we know that in this time frame there was a really violent explosion in space, and we know that it lasted about this long, and we can understand how much energy, how energetic it was, all just from the data that we get from GMOD.
The detectors on the payloads, on the experiments, those were the things that we built completely from scratch ourselves. And then we bought off-the-shelf components for power and for the computer and for the comm system. And then it was like a bit of an effort to sort of put those together in a way that would work and make sure that they would all work together. When we were like really deep in the design aspect of the satellite, it would just sort of seep into my dreams. Like I'd wake up in the middle of the night, I was like, oh God, I can't put the GPS module there. Like this isn't going to work.
Why do we test spacecraft? Because space is hard. Space is very hard. And it starts on the ground. And, it's really a hostile environment. And the big problem we have with space is that if something goes wrong, you cannot just, get on your car and drive there and fix it.
It's really hard to test the satellite in a meaningful way in your university unless you have like a dedicated space test facility, but we have that. We have the CubeSat support facility where they can bring their CubeSat or bring parts of their CubeSat, and they can shake it to simulate the launch environment. They can put it in the thermal vacuum chamber to simulate the deep space environment. And we have access to other facilities as well, so they can do like antenna testing, for example, here at ESTEC. So this is the Hertz facility at ESA's ESTEC site in Noordwijk in the Netherlands. And this is a room which is used for antenna and radio frequency testing. So that's immediately cool. And then you have this huge chamber full of these blue spikes. The sound's weird, the light's weird. It's a sci-fi experience.
It's definitely nerve-wracking. I think the thing is there's so many components and so much can go wrong. And even though you work really hard to try make sure everything's in its place and everything's well tested and well qualified, you never really know. And I think each campaign we've come up against at least one or two things we didn't expect. So it was just a huge, steep learning curve, and there were challenges along the way, but it's all been worth it. I know myself, I've kind of, even like after a day of testing, you're at home and you're like, did I turn off the spacecraft? That kind of stuff as well. Like it's just, and it's like really weird to be at home cooking your dinner and thinking, have I turned off a spacecraft?
We knew this would be a way to inspire young people in the country, not just about space, but about STEM and about, being bold and going after your dreams. Ireland is a great tradition of writers and writing, so we thought one brilliant way could be to connect AirSat 1 to Irish writing, and that was the beginning of the poem. The poem is called Always Home, and it came about through a collaboration with creative writers in English in UCD and the Museum of Literature Ireland. They had the network of librarians throughout the country who brought the school pupils together with the writers to create the poem over a series of workshops that were held online during lockdown. So the poem is etched using a laser onto the outer cover of the antenna deployment module on the spacecraft. The antenna we use to communicate with the spacecraft, and that the spacecraft uses to communicate to us back on Earth.
Think warm, think warm, think warm. Very hot, very hot, very hot. We're here on the roof of the physics building in UCD Dublin, and this is where AirSat has its primary ground station. So this is the connection point where AirSat basically can talk to us, and where we talk to AirSat, but also where we collect all the data. My name is Bas Steijnen. I'm currently a PhD candidate here in the School of Mechanical and Materials Engineering, and I'm also a member of the AirSat 1 team. So we have our primary ground station here. We are very close to the sea here, so there's sometimes lots of hard wind or harsh weather. We would like to have a backup ground station, or a secondary ground station as we call it. The secondary ground station of AirSat is on our family farm. We chose that location because it is as far west from Dublin as we can possibly get in Ireland. So we're a small sheep farm. It's very hilly, it's very inaccessible, most of it, but sheep absolutely love that, so that's totally fine. There's going to be a lot of students involved in this project, and we hope to give all of them the opportunity to operate the satellite, but also to do the science that this little satellite will produce in data. Until we hear that first signal via our ground station, it's going to be really nervous. We're going to be really nervous from the moment it leaves the launch pad till that moment that we can hear that first beep, basically.
Once we have operations going, I'm really looking forward to bringing on the next generation of students who now have a satellite to operate, who now have data they can take from our own satellite to analyse. So it's really coming back full circle to where we started with the project almost, except we're now able to bring the educational aspects up a whole other notch, because we actually have spaceflight hardware, we have an operating satellite that we can train students with.
It's extremely rewarding to be involved in the launch of the first satellite of a nation. Ireland will become a spacefaring nation through AirSat. We had to collaborate closely with the legal department at ESA, with the authorities in Ireland to make this possible. There was no domestic legislation regulating space activities. It's probably as complicated to pass through all the legal processes as it is to pass through all the engineering challenges to launch the first satellite.
In fact, actually, these legal matters came to light as a result of the legal and policy analysis undertaken by officials in our department to ensure that there was a supportive legislative and policy framework in place for the future launch, maybe sometime this year or early next year, of Ireland's first satellite, AirSat-1, by the UCD as part of the European Space Agency's Fly Your Satellite programme. I'm delighted that the team from UCD are with us tonight here in the gallery. But it'll be a proud moment for Ireland when we can see the fruits of their work in the months ahead. They've been very busy in UCD for the last number of months, and I'm glad they're here. Part of the satellite programme there at AirSat-1, with Lorraine Hanlon, with David McKeown, Gabriel Finneran, Joe Thompson, Joe Mangan and Ronan Wall. I think I've covered everybody. I hope I'm missing nobody, but they're doing great work from an education point of view as well.
They would associate kind of launching spacecraft with the big space agencies in America and Europe. They wouldn't think a college or a university in Ireland would be able to kind of be part of that community of launching spacecrafts.
It's a much more lively, active place for space these days than it was 6 years ago when we started. Like we wouldn't have gotten here without the people at ESA that we have access to. And when they sort of endorse your project, it's like it gives you credibility. Other people start to listen to you and believe in you as well.
No? Yeah, just at the right height. Okay, you need your tilted down, so you need to lift your end a little. Yeah, now don't go any further than there. Okay. Okay. How's the RBF?
Get a little bit further I can go.
It's going pretty easy, right? You don't feel it. Yeah. Get in.
Following this.
Oh, get me a tissue. You better turn on there.
Not now.
Not now.
Not now.
Yay! And I have a question. I don't know if I can do this again. Congrats!
You'd be surprised how little you need to start with a CubeSat project, because you really just need an idea. And things will build around that. You can be a team launching a satellite. In some cases, you can be a team launching a satellite, the first satellite for your nation.
You know, like 6 years later, all the work we've poured into it, maybe the worst that can happen is you actually get accepted.
Joyce believed he could do anything with words.
Always home. A lone pilot searching for home amid starry frescoes and little blood waves that mimic the tide pull.
Our insignificance. Our planet a crumb on the fabric of space-time.
Sharing the same sky, you and I, wherever feet are anchored.
I will write your name on the moon with my fingertips, an apparition cast for memory's design.
Universe whisper, orange as goldfish. All I want is the delicious scent, the dark blue muddy shoes.
And ruined grass of starlight, home. Strawberry moon in the cloudless blue, black mystic. One day it could all be rain.
Those windswept words, voices clutched to our warmth. Courage plucked from conversation. Breeze breath, feel the blush dust my cheeks, the stars like old photos.
Leave the porch light on. The children dance, their mothers sing. Everything changes all at once. The sky, the sun.
Bound with images of mystery like lemongrass and sleep, except for the tree.
I look up, I see stars. They live forever inside me.
Home is the wild bitterness of backyard blackberries.
A bay tree, its fragrant leaves, breathing easy. A smell so familiar, it has none.
Bye.
Bye.
Bye. Bye.
Bye.
Bye. Safe home.
Bye.
Bye.
Bye. Bye.
Bye.
Bye.
Bye.
Bye.
Bye.
Bye.
Bye. Did anyone turn off the immersion?
13 years in space with the immersion on.
Rack up some bill.